write these two numbers in scientific notation. So the first number that we're given is, that's thousands, million, 42 million. So if I wanted to write this number in scientific notation, I would begin by placing the decimals right there, right? And I would say to myself immediately, well, that's not the number you have, right? You don't have 4.2. You have a much bigger number. And in order to write in scientific notation, I do have this 4.2, but then I need to multiply by a whole bunch of tens. And I can ask myself, well, how many times do I multiply by 10? I might, for example, say, well, I'm starting right here, that's 4.2. And every single time I move this green line to the right one, that's another 10. So I can say I'm going to multiply by 1, 2, 3, 4, 5, 6, 7 tens. So this number is 4.2 times 10 to the 7th power, right? Multiplying by more tens. The next one I have is a smaller number, right? It's expressed in inches. It's a small number of inches. In fact, it's a small fraction, a tiny, tiny fraction of 1 inch. I'm going to do the same thing. I'm going to write this as 5.12, but this time, instead of multiplying by powers of 10, I'm going to be dividing by 10. Or the other way of thinking about that is I'm going to be multiplying by negative powers of 10. Remember, if I have 10 to the negative 1 power, that is equal to 1/10. So every single time this exponent increases by 1, that means I'm dividing by another 10. So if my value, if my decimal is right here, and it is, I need to go to the left several times. So each time I'm dividing by 10, so I'm just going to count how many negative powers of 10 I need. Well, that would be 1, 2, 3, and 4. So this answer is 5.12 times 10 to the negative 4th. Again, 1 is where that's where I start. I'm sorry, I start there, but it's 1, 2, 3, and 4. All right, that's it for question 7.